Hello everyone, welcome to the Gate Academy. Guys, today in this session, we are going to do the previous year questions of the subject Fluid Mechanics asked from IIT Kharagpur. Okay, so again, I welcome all of you on behalf of the Gate Academy. And before continuing with the session, I would like to request you to like, subscribe, and share the Gate Academy YouTube channel. Okay. So, my dear, in this session, we are going to solve. So, this year we know GATE 2022, the organizing IIT is IIT Kharagpur, right? The organizing IIT is IIT Kharagpur. Okay. So, now in this session, what we are going to do, we are going to solve previous year questions which were asked by IIT Kharagpur, IIT Kharagpur from the subject of fluid mechanics. So, guys, you can talk to me in the live chat session, in the live chat section of the YouTube, and we can have it solved. We can have to try to solve the questions that we see in the GATE previous years of IIT Kharagpur. So here we go with the first question. So guys, please tell me the answer of this question. Please try to solve this question. I am very sure that you guys can do it. So please try. We'll be taking a minute for each question. Okay, and I hope all of us can try to solve this question. I hope all of us try to solve this question. So this question belongs to the GATE year 2006. This question belongs to the GATE year 2006. Okay. Okay. Please try. I am very sure that we can solve it, my dear. I am very sure that we guys can solve it. Okay. What is the answer to this question, my dear? What is the answer to this question, my dear? Can we please try? What is the answer to this question, my dear? This is a very simple question. GATE previous year question. For a Newtonian fluid, the stress is proportional to, we have to choose the correct option. This is a MCQ question, multi-choice question. So for a Newtonian fluid, the shear stress is proportional to shear strain. Rate of shear stress is proportional to the shear strain. Shear stress is proportional to the rate of shear strain, or the rate of shear stress is proportional to the rate of shear strain. So what is the answer to this question, my dear? Please tell me the solution of it. Please tell me the solution of it in the chat box of the YouTube. What is the answer to this? What is the answer to this? So this question, are Newtonian fluid. So we know for Newtonian fluid, which law is the governing one? So we have Newton's law of viscosity, right? We have this Newton's law of viscosity. We have this Newton's law of viscosity. And what does Newton's law of viscosity says? Tau is equal to mu du by dy. So what is this tau, my dear? Tau is the shear stress. Tau is the shear stress, and du by dy is the rate of shear strain. Rate of shear strain. Okay. Rate of shear strain. So what is the correct answer to this question? The correct answer to this question is option C. The shear stress is proportional to the rate of shear strain. I hope any doubt, in case of any doubt, please feel free to ask me. See why we are, so here we go with the second question. So we'll try to do as many as questions quickly as possible. Okay, so obviously so many questions are asked because so many years, 6 years, IIT Kharagpur has been the organizing IIT, so almost 40-45 questions are there of fluid mechanics. So we'll be doing 6-7 questions in this session, and maybe in some other session we'll be going to do some more questions. So here we go with the next question. Please try to solve this question, please. Can we try to solve this one? This is a question of 1988. Okay. This is a question of 1988. So I'm very sure we guys can try to solve it. Please try it, my dear. This is a previous year question of fluid mechanics from the year 1988, in which the organizing IIT was IIT Kharagpur. And as we are aware that this year, GATE 2022, also the organizing IIT is IIT Kharagpur. The organizing IIT is IIT Kharagpur. Okay, and so obviously, from solving the previous year questions asked by the IIT Kharagpur in any subject, we'll get the idea of what kind of questions they are asking in the GATE paper. Okay, because what is the sense behind it? Although it is not necessary that they will ask the same kind of a question, but see, there is a pattern of each IIT, right? There is a pattern to each IIT. We get the idea about what is the amount of complication, what is the amount of complication of the question, how complicated it is, what is the level of it. Very good, Shreyas. You have given the right answer. That is the correct answer. That is the B. So this question belongs to the chapter. This question belongs to the chapter of hydrostatic force on the surface. So here we have to find the total hydrostatic pressure force. So we know the hydrostatic pressure force is given by rho g a x bar. Yes or no? Rho g a x bar. So your hydrostatic force is given by rho g a x bar. So what is this g, my dear? What is this rho? Rho is water. So for water, we very well know the density is 1000. G is 9.81. Area, so circular plate of 1 meter diameter. So we can do it pi by 4 into 1 square. And what would be this? What would be this x bar? So x bar, please understand this. X bar is the distance of the centroid, of the surface from free surface of liquid. So here in this case, it is water, from free surface of water. So what is given to us? Circular plate. So it is basically water, such as upper edge is 8 meter below. So it is somewhat like this. So we have, let's say this is your plate. So its top edge is 8 meter below the surface of the water. So this is 8 meter and the dia is 1 meter. So where will be the centroid be located? So centroid will be exactly at the geometrical center. So this is your G and this is your X bar. So obviously your X bar, very good. Very good, Shreya. So X bar is going to be 8 plus 0.5, that is 8.5. So when we solve this equation, when we do the calculation of it, we'll be getting nearly 65.45 kilonewton. So by solving it, whatever you get, divided by 1000 to get the answer in kilonewton. So the answer of this question would be 65.4 kilonewton. Right, madam? I hope we do not have any confusion in this question. So let's move to the next question. So here we go with the another question. Let's see if we can solve it or not. So this is a question of GATE 2000. This is a question of GATE 2000. Again, the organizing IIT was IIT Kharagpur. Okay. So this question belongs to a simple manometer or piezometer or pressure measurement. This question belongs to simple piezometer, manometer, or what you can say pressure measurement, from the topic of pressure measurement. Okay, let's try it. Let's see if we can do it or not. Please try it, my dear. Though I am expecting that many of you must have solved these questions before while practicing the questions, right? While practicing the questions. Very simply, we can do it, and the options are these: 26, 50, 76, and 126. So, what should be the answer to this question, my dear? Very simple question. Very simple question. Vignesh, I'm very sure that there is a lot of time if you start from today. These are the options, my dear. Okay, these are the options, Suresh. Vignesh Murthy, still we have time to revise and practice questions for all the subjects. Okay, but you start from tomorrow or today only, right? So, what are the options? So, very simple question it is basically. No need of any calculation even. So, first of all, can you guys tell me the pressure inside this pipe or bulb, what they are calling it, is vacuum or not? So by observation, we can say that the pressure inside it is of vacuum. Yes or no? So this is a simple piezometer. This is a simple piezometer. This is a simple piezometer. Now in a piezometer, as we know, we find the pressure by simply the formula rho g and h. Okay, rho g and h. But here in this question, they are asking you the height of the column h. So see, this is given the pressure inside this bulb is given in terms of mercury only, in terms of mercury only. So either you can change this first to the Pascal unit and then equate with the rho gh, or you can directly say, so since the pressure is in mercury is given in the terms of mercury, and here it is also mercury, and the column is also of mercury, so directly we can say this column would be 50 centimeter of mercury. So what would be the answer to this question? The answer to this question is B option. Is it clear to everyone? Please answer me. Vignesh, so obviously, so when you have completed all the lectures, my dear, so why to worry about? There is a lot of time left for revising and practicing, and you have to do it again and again and again. Okay, so this question is fine. No, very simple question. See, pressure inside the bulb is given in terms of mercury. The liquid column is of mercury. So both will be getting the same solution. Right, my dear? Okay, now let's see this question. So this is the question of IC of which year? This is the question of IC which year? This is the question of 2014. 2014 again the organizing IIT was IIT Kharagpur. Okay. 1988, 1994, 2000, 2006, and 2014. Now in 2022. Okay. So again, a very simple question. I am expecting the answer here. Darshan, right answer. Beta Keshav, right answer. Very nice. Very nice. Very good. What about the rest of you? Vignesh, Shreyash, and all the other students attending the live session. Okay, so for a completely submerged body, with center of gravity and center condition of stability. So when I teach this, I give you this example, right? If you remember or have attended the sessions of the Gate Academy. So this is a toy. If you remember, this is a toy that we know hit me not. So whenever you give a unbalanced force of it, whenever you kick it to some extent or you punch it, whenever you punch it, it will be going downwards and then it will come back to its original position. Okay. So what is the center of gravity? So center of gravity is the center at which the weight is acting. The center at which the weight is acting. So it is somewhere, you see, it is somewhere here, because there is a weight in the bottom of it, and it is displacing the volume. So much volume it is displacing, so what is the center of buoyancy? Center of buoyancy is the centroid of the volume displaced. Okay, so this is what we can say. B is above the G, or G is located below B. So the solution to this question is A option. Always remember, first of all, so whenever we call about this stability thing, people start thinking about this meta center thing. So meta center is only there. Meta center is only there for partially submerged body. For fully submerged body, meta center has no play or no role. Only the role is of center of buoyancy and center of gravity. So if center of buoyancy is above the center of gravity, it is in a stable equilibrium. Otherwise, it is in unstable equilibrium. I hope it is fine for you. Now, can we try this question, please? Can we try this question? Again, 2014, we had 4 sets. 2014, we had 4 sets. So can we try this one? Very simple question of fluid statics. So this is a numerical ability type question, beta. You have to give me the numerical answer of it. Please do not forget to subscribe the channel as well. Because we are frequently coming up with many important and you see many informative videos for you guys. Is it done, my dear? So what we know, so we have to find the difference in pressure across an air bubble of diameter. So diameter is given to us. Immersed in water with surface tension is this. So what is the pressure difference? So if we remember the formula, so it is 4 sigma by R. Sorry, 2 sigma by R or 4 sigma by D. Okay. So sigma is what? The surface tension. So surface tension is 0.072 and radius is 0.001 by 2. So by solving this equation, I am expecting that we'll be getting 288 Newton per meter square. Are we getting that, my dear? Are we getting that or not? I hope we are getting that. So very simple question, direct formula based question. And we know there is a excess pressure intensity inside the droplet of water or a bubble. Okay, so this is the formula. Now coming to this question, let's try to solve this. Again, a question of 2014. Organizing institute was IIT Kharagpur. Subject fluid mechanics. Topic fluid statics. Subtopic buoyancy. Let's see if we can do it. Please try it. Very good, Keshav. Very good, Manikanta. Basically, it is a question of fluid mechanics as well as casting. So how we can solve this question? So basically the net buoyancy force that we have to find is in case of a core, so it is given by rho of, so whatever material you are casting minus the density of the core into volume of the core into G. So this is the standard way, right, my dear? Density of aluminium minus density of core into volume of core into the gravity. So simply we can place the values here. So density of aluminium is 2600, density of the core is 1600, volume of the core is pi by 4. So what is the diameter of it? 100 square. So 0.1 is square, and length is also zero point 0.1 square. Sorry, 0.1, because we know volume is area into length, and G is 9.81. G is 9.81. So I hope we can solve this question. So equation. So when we solve this equation, we'll be getting 7.7 Newton. Is it fine to all of you, my dear? Is it fine to all of you? Please answer me. Please answer me. Okay. Okay. Now moving to the next question. So this is again a question of GATE 2014. The organizing committee was IIT Kharagpur. Organizing IIT was IIT Kharagpur. So today this is the last question, and with this question we'll be ending up. We'll be ending up the session. With this question we'll be ending up the session, and all the question of fluid statics asked by the IIT Kharagpur will be completed with this question. Okay, so obviously we can't do all questions in one session of fluid mechanics, because 45 questions are asked in the GATE examination from the subject fluid mechanics till this time. So we are dividing it. So we have in this session completed IIT Kharagpur previous year question of fluid mechanics from the section of fluid statics. Okay, can we please try Can we please try it, my dear? Manikanta, for this, sir, how to prepare for next 4 months for GATE? So what should be the right strategy for that? So I'll be coming up with one video on 16th of September on this channel only. Okay, so you subscribe the channel, you will get notified about it. So in that session, we'll be talking about that what should be the strategy for us for the remaining time. Okay, so whatever time is remaining, what should be the strategy for that? What should be the strategy for that? We'll be talking about it in a dedicated session because it is many discussion is required, many things I want to tell you. So it is not possible in today's session because the agenda of today's session is somewhat different. So again, I'll be requesting you that please do not forget to like and subscribe the channel because see all these notifications are we are going to have if we subscribe the channel. So please do share and subscribe for it. So what is the answer to this question? Can I have the answer, please? Very good, Manikant. Correct answer. What about the rest of you? Yes, Pankaj. Okay, so I hope you guys have attempted it. So I'll be doing it. So let me share. So I hope because I require some space for it. So I have changed the screen. Very good, Keshav. So I'm expecting that all of you must have attempted it. So now we can see this question here. We can see this question here. So a spherical balloon with a diameter of 10 meters shown in the figure below is used for advertisement. The balloon is filled with helium. So there is helium inside this balloon with R. So this is a somewhat concepts of thermodynamics are also involved and the concept of fluid mechanics are also involved in this question. At ambient condition 15 degree and 100 kilopascal, assuming no disturbance due to wind, the maximum allowable weight of balloon material and rope required to avoid the fall of the balloon. Required to avoid the fall of the balloon. So basically, we have a spherical balloon whose diameter is given. The balloon is filled with helium, so there is helium inside this balloon. Ambient condition, temperature, pressure is given. So we have to find the weight of the balloon material and the rope. We have to find the weight of the balloon material and the rope required to avoid the fall of this balloon. Required to avoid the fall of this balloon. So basically, how we can do it? Basically, how we can do it? So if we do the balance of the forces, so we know that the weight of helium will be acting downwards, weight of helium will be acting downwards, plus the weight of the balloon material, if we say, plus the weight of the balloon material, plus the weight of the rope, and they all must be equal to the Buoyancy force. Because if it is in equilibrium condition, if it's a static condition currently, so this should be the case. This should be the case. So what should be the weight of the balloon material plus weight of the rope? So it should be the difference of the buoyant force and the weight of the helium. The weight of the helium. Okay. So what is the buoyant force? So buoyant force we know is the weight of the liquid displaced. Okay. By the immersed portion of the object. So this is fully submerged. So what is first of all what the fluid it is displacing? So it is displacing the air. So I must be using the density of the air into G into volume of this balloon. So this much is the buoyant force minus weight of the helium minus the weight of the helium minus the weight of the helium. So what is the weight of the helium? So density of the helium into G into again the volume of this balloon. So basically all we have to do, we have to do it by this way. We have to do it by this way. I hope it is fine to all of you. I hope it is fine to all of you, right? Right. So now we have the G, we have the diameter. So volume we have, so we know it is pi by 6 d cube for the sphere. For the sphere, it is pi by 6 d cube or 4 by 3 pi r cube. 4 by 3 pi r cube. So basically, we are getting 523.33. 523.33 mm cube is the volume of it. 533.33 mm cube, 523.33 mm cube is the volume of it. So if we can find the density of air, will be fine. And if we have to find the density of helium, this is two things we have to find. Now for this, we know equation PV is equal to MRT because both helium and this air both are ideal gas. So if I do mass by volume, that is the density. So basically this is P by RT. This is the density P by RT. Now density of air will be, so pressure is given 100 kilopascal. What is the R for the air? So it is given to be 0.289 kilojoule per kg Kelvin. Kilojoule per kg Kelvin. And what is the temperature? Temperature is 15 degrees. So do not forget to change it in Kelvin. Whenever we are using the ideal gas equation, the temperature should be in terms of the Kelvin. Okay, so this is going to be 288. So from here we can find the density of the air. From here we can find the density of the air. Okay, from here we can find the density of air. Now in the same way we can find the density of the helium. In the same way we can also find the density of the helium. So pressure again is 100 kilopascal. What is the characteristic gas constant? It is R given. So R is given to be 2.08. The temperature is 288. The temperature is 288. So from here we can get the density of helium. From here we can get the density of air. Density of air, and we can place this in this equation number 1. We can place this in equation number 1 to find the answer. So when we put everything, we'll be getting how much? We'll be getting 5305 Newton as the answer. 5305 Newton as the answer. So have we understood this question, my dear? Is it fine to everyone? Please answer me. Is it fine to everyone? Please answer me. Right? So in this session, my dear, let's end the session. In this session, my dear, we have seen previous year fluid mechanics questions of IIT Kharagpur, and we have completed the questions up to fluid statics. Okay, so in today's session, we have completed the question asked from IIT Kharagpur in fluid statics. Oh, Keshav, today, so we can ask it when in another session. Okay, or you can message me personally, right? Because here the agenda is different now. Okay, so you are obviously in personal contact to me. So basically, you can message me there. Fine. Okay. Okay. So, my dear, please do not forget to like and subscribe the channel, and do share amongst your friend. Do share amongst your friend, and please be live in the next session on 15th of September. We are coming up with theory of machine previous year questions of IIT Kharagpur. Okay, so please do join live with me, and we'll be solving questions so that our preparation will be given a boost. Okay, so do not forget to like and subscribe, and I hope you like this video. Thank you very much.